Okay, this is the fourth video. This one will take you through creating a player character for a platformer that can like stand on platforms, fall under gravity, and not walk through platforms. Okay, so there's a little bit of setup involved in doing this, so this is a little bit technical. I'll take it slowly and try and explain as we go along. So what we're going to do is we're going to start with level, okay, and we need to set up a few routines, a few methods that are going to help us with collision detection. Okay, so if you find your level class, and we'll just go to the top above where the constructor is, and we're just going to create a list. So we type the word list, and then we put angle brackets like HTML, and we just put int. So it's going to be a list of integers. We're going to call it platforms. Okay, and we're going to say equals new list int bracket bracket and then a semicolon. So I'll just zoom that in a little bit so you can see that. So that's going to hold a list of valid platforms. So when we're doing collision detection, we're going to create another one to give a list of passable tiles, which for the minute is just going to consist of empty tiles, which are -1. So we're going to say list int passable equals new list int, and then we're going to put a curly brace and we're just going to put a -1 and then a semicolon at the end. So we're saying that that list just contains -1. We're going to populate this one in a minute with some values. Okay. Right, so in the constructor, so we got all the stuff we had before, generating the map, the level viewer. Okay. After the level viewer, what I'm going to do is I'm going to create a new method. So I'm going to say set collision method data, we'll call it. Right, that'll have a red squiggle because it doesn't exist. So we're going to do control full stop, and then we're going to select generate method, and it's going to create it for us just down here. Okay, we don't want the not implemented exception, so we'll delete that line. And then we're just going to set up our platform data. Now this will change based on your game, but I'm just doing it for mine. I've got 3 different tiles that I consider platforms or walls, so they're all going to be collision detection things for me. Okay, so I'm just going to say platforms dot add, and then it just wants a number, so we can say tile index, and then we're going to put a square bracket. So let me just zoom this in a little bit more. Square bracket, and we're not going to say square bracket, we're going to say tile index dot index of, and we're going to give a single quote, and we're going to say whatever the X character tile was. Okay, let's do that again. We've got to add the other 2, so that's platforms dot add tile index of, and then in the brackets we're going to put M, because these were the 3 tiles I had. And finally, platforms dot add tile index of, and it's going to be W, I think. Capital W is the other one. Okay, so if you've got more platform tiles, because you might have funny shaped tiles and things, you add these in. We're going to set our code up so that it will work with any number of tiles. Okay, right, so that's that bit. We're then going to create our helper methods that will do the collision detection for us. So we're just going to go down to the bottom. Oh, we don't have to go down to the bottom. We might as well just carry on. So after the set collision data method, these have got to be public because we want to be able to use these. So we're going to create our first one. We're going to say public bool, because it's going to return true or false. True if we have hit a floor, or false if it isn't. And we're going to call it IsFloor. Then we're going to open a parentheses. I'm just going to zoom that again. Let's just get rid of this. Oh, no, I'll leave that on. And it's going to need a parameter, so we're going to give it a tile location. Okay, then we're going to press enter, and we're going to do a left brace, and it'll automatically put a right brace. If we then press enter, we're ready to type our code. And all it's got is one line, and it's just going to say returns platforms, which is the thing we've just defined. Oh dear, return platforms dot contains, and then we're going to say bracket get graphic bracket location. Okay, so we're basically saying at the given tile location, does it have one of our platform? Is one of our platform tiles? Okay, if that's true, it returns true. If it's false, it returns false. Okay, so we're just working out if it's a floor. Okay, so let's create another helper. So that one was for a tile location. Now we're going to check a point. So it's going to be similar. So we're going to say public bool, and we're going to call this one in platform. So we can use this for bullets to detect whether a bullet's hit a block and then we want to destroy it. So we can do that. So we'll use that later. Right, so this time we're going to give two parameters, an X and Y position. So that's going to be float X, comma, float Y. Then we're going to do a left brace, press enter, and we're ready to type. So the first thing we've got to do is work out what tile location that's at. So we just say return platform. Oh, I'm being a div here. Hang on. Point tileLoc equals location X, comma Y. So that'll work out for that pixel position what tile location in the tile map that is. And then we can just say return, so it look a little bit like what we had up before. So it's going to be platforms dot contains contains use the picker as much as possible. Then you won't make stupid mistakes like I just made. And then we're going to say get graphic and tileLoc. Okay, so that's the two simple ones. So we've got one that'll check to see if a tile is a floor. Another one that would say, is there a point inside a platform? Okay, so we're giving them sensible names. Okay, two more helpers. They start getting a little bit more complicated, but only if they only look more complicated. They're not really. Right, so the next one is going to determine if a series of positions, and you'll see why we do this later on, a series of positions that we give it are inside a platform. Okay, so it's going to loop round each position it's given and say, right, okay, if we've hit a platform, we're going to return true and say, yes, we've hit a platform. If it goes through all the positions and none of them are in platforms, it's going to say false. Okay, so we'll do this one just under in platform. So we're just going to say public bool, so it's a true or false value again. And we're going to call it touching platform. Let's call it in platform just to show you a bit of overloading. So we can say in platform, and it's going to have two parameters. So the first one's going to be a center position. So we're just going to call that center. So vector2 center. So that's the center of a sprite or whatever object we're testing. And then we're going to get a list. So we're going to say list vector2 of offsets. Okay. So put a brace, press enter. Let me just scroll that up. So we're going to give it a center of a sprite and we're going to get a list of offsets, so positions around the sprite that we want to check. Now this is important in a platform game because you could just test the center of a sprite, but if you go more than halfway off the edge of a platform, you'll fall. So we want to be able to give it a number of positions that we want to check. Okay, so that's why we got these. Don't worry about how this looks a bit horrible. It just means it's a list of X and Y positions. That's all that means. Okay, you'll get a red squig because we haven't finished the code yet. Right, now we're going to write a loop. So this is going to be a special kind of loop called a for each. So we're going to say for each, and we're just going to use the picker. And if you see, it says snippet. So what we can do, it says press tab twice. So I'm going to press tab twice, and it builds the code for me. All right. Now it's moved over over here. Okay, so it said var and it's got a name item. So if you just press tab again, we can just give that a name instead of item. So I'm going to call it distance. And then I'm going to press tab again. I'm going to change collection to offsets because that's the thing I want to go through. So I want to run through this list of offsets. Okay, now I can change, for readability's sake, I can change this var to vector2, which I think I'll do. So I don't have to get into what vars are. Okay, right, so all we're going to do for each one of these offsets, we're going to say, is each one of these offsets in a platform? And we're going to do that. I'm just going to zoom out a little. So I'm going to say inside these braces, notice it put those in for us. We're going to say in platform, and we're going to say center.x plus distance.x, comma, center.y plus distance.y. And I'm going to say parentheses, parentheses, semicolon. No, we're not going to put a semicolon. You mustn't do that. Press enter and then say return true. So if we found that one of these positions in this list is in the platform, we're going to return true. Okay. If we've gone through the entire list, so we're after the for each loop, and we haven't hit a platform, then we're going to return false to say, sorry, I looked at them all, no platform. Now what's interesting here is we've got two methods called in platform. This is what we call operator overloading. All right. So we've passed different data. So when we pass just an X and Y position, we want to run this version. If we pass it a center position, a vector2, and a list of positions, then it'll use this method. But it gives us a nice way of using the same name for slightly different meanings. Okay. Right, the final method, helper method that we've got to create in level. So just below in platform, just put a few blank lines in. Right, now this one is going to be used when we're falling. So if we're falling and we find that we hit a tile, what we'll want to do is sit the sprite actor on top of that tile. Okay. This is important because if you don't do that, you'll sink into a tile because you can fall at different speeds. And then you won't be able to move left and right because you're embedded in a tile. So we're just going to sit them on top. So constantly the sprite is falling and we'll be constantly running this routine. So this is a little bit more complicated, not much. It's got a couple of lines, but I'll explain it as we go along. So again, this is going to be a public bool. So this is going to return whether it managed to sit on top or not. And we're going to call it sit on top. Notice I've capitalized. Okay, that's quite important. That's called Pascal casing. Right, so this one again is going to have two parameters. We're going to pass it a sprite called actor, and we're going to put a comma, and we're going to again have a list of offsets because there'll be various positions we'll need to check to see if any part of our sprite is sat on a platform. Okay, that's important to us. So it's going to be a list of vector2 again, and it's going to be offsets. So it looks a little bit like the one we had above for in platform. Apart from this time, the first parameter is a sprite. Okay, press enter, do your left brace, press enter again, and then you'll be able to start typing your code. So the first thing we're going to do is we're going to get the game engine to give us a list of all the tiles. So we're going to say list point, that's what tile locations are, and we'll call it tileLocs equals, and then we're going to get the game engine, and we're going to say, right, wherever the center of the actor is, actor.center2d, and we're going to give it that list of offsets. So it'll actually look and find all the tiles that that potential actor could be sitting on, because it could be sitting on 2. It could be sitting on more, depending on how small your tiles are. So we get that list. And then we're going to run through this list, but this time we're going to do a different type of for loop. We're going to do a normal for loop. So again, I'm going to type for, and you'll see I get the snippet thing come up again. So I'm going to do tab twice. Right, so this time I've got an index. And it's picked I, and I'm going to keep I because it's nice and short. I'm going to press tab and it's going on to the length part. So I'm going to change the length part. I'm just going to type tileLocs, that's what I've just created, dot count. Oh, I've done copy too. So delete up to the dot count. Okay, use the picker so you get the case properly. And it's done I++, so that just means add 1 each time around the loop. So this I value, this one, this index, is just going to go up by 1, start at 0, because that's the first item in this list. Okay, and we're just we're going to use this now to just do some potential sitting of a sprite on top of a tile. Okay, so this line looks a bit long, but I'll type it slowly, and you can follow along. Let me just get rid of the Solution Explorer so you can see more of my screen. So scroll that up a bit. So I'm going to say if, and then open parentheses, and I'm going to say set actor on graphic tile. So a bit of a mouthful. Use the picker so you don't type it wrong. Then I'm going to open another left parentheses, and I'm going to then pass it actor, the list, the specific tile location that I'm trying, tileLocs bracket, and that's the square bracket I. Then I'm going to set it the center, the X center, so that's actor.center2d.x. Then I need to give it the offset position. So I'm going to say offsets square bracket I dot Y. Use the picker, it's a capital Y. Then I've got to give it a tolerance value. So how many pixels am I considering within the tile? So that depends on how fast you're falling. So you may need to play about with this. I'm going to use the number 2. Okay, so I'm going to say 2 pixel tolerance. And then I need to give it a set of tiles that we're allowed to move through. So that was our passable thing that we created right at the start. Okay, and we called it passable. So just put so what we're doing on there is that it's going to attempt to see if we can sit the actor sprite at this tile location. Okay, so we just give it the center and the depth, the offset from the center that we want. You'll see the offsets later when we create those. And we just say, right, well, within a couple of pixels, depending on how fast we're going. And then we're just giving it a list of tiles that we're allowed to move through, which currently for us is just -1. So if we just scroll up, I haven't finished that code yet. See, that was the passable list. Okay. Right, if that is true, so if we press enter, we're going to say return true. We're going to stop. There's no point. If we've sat it on one tile, there's no point in checking it for any others. Okay. If we go through the whole list and we didn't actually find a tile to sit on top of, we're going to return false. Okay, so let's just recap that. So we've got a little helper routine that's going to try and attempt to sit us on top of a tile for when we're falling. We've got a routine that's going to check a load of sprite positions to see if they're hitting platforms. We've got an individual routine that'll say if a pixel's within a platform. And then we've got another routine that checks to see if a tile location is a platform. So they're all our little helper routines. Okay. Right, we're halfway through. So we've done all the donkey work. Like I say, if you've got some different tiles, you'll need to add them into your set collision detector. Right, let's go to the routine in Level that generates our sprites. So quick way of doing this, I'm in Level already. So if I go to this right-hand drop-down box, and that was called, I can't remember what it's called, generate sprites. Okay, so I had this in the previous video. I didn't actually use these, but I've got one that sets up my player character. So I'm just going to uncomment this code. You might already have this uncommented. Okay, so I'm uncommenting that, and I'm going to create this player sprite. So I'm just going to quickly take you through creating this player sprite, and just to show you, I borrowed. I'll just load this up. It'll probably load up. Oh, it's loading fireworks. Sometimes mess it up on me that. I borrowed a not very well known character from a really old game called Donkey Kong. Okay, just to make a little running platform character. He doesn't really play platform games, it's Mario. Okay, so we're going to use this and I'm going to show you how to do pixel based animation. So as you move, you animate. Okay, so I'm going to show you how to do that. In the same way that I've shown you before, we can define number of frames. I know the numbers, so I'm just going to put the numbers in, but that's what I'm going to use. Okay, right, so back to level. So I've got this new player character. I need to create this sprite, so I'm going to say control full stop over player, and I'm going to say generate class for player 2. So you might have this. I'm just having to make this because I haven't got it. So I'm making it in a new file. So it should have created up at the top. It hasn't got all the different using statements at the top. So I'm just going to copy them from coin. At the end of your building your game, if any of these are grey, like they all are now, you can delete those ones because they're not being used. But it doesn't hurt at the start. Right. Okay, so I've got this basic class, but I know it needs to inherit from sprite, so I'm going to put that in there. Right, so we've got these parameters that it's set. So I'm going to say y, change that parameter to y. I don't need to actually store the bottom, so I'm going to delete the fields bottom and x. I need the level because that's what I need to do my collision detection. So I'm going to get rid of these two references that are now broken inside the constructor to x and bottom. Don't need those. Okay, so I've got my level. Whenever I create a sprite, I've got to make sure I do engine manager.add sprite. This, if I don't do that, it won't get rendered. Then I'm going to define my frames. Okay, so I'm going to say frame dot define, and it is gm.tx sprite, and the rectangle, I know because I've written it down, is, I'm going to look foolish if it's the wrong rectangle, but 153 40, 40. So I'm going to be naughty and copy paste that. So the second one was 40. So you can use this if you want, but you could substitute for your own animation graphic. Remember, the more frames you've got, the more definitions you've got to make. And then I'm going to set the animation up. So I'm going to say frame dot animator dot, and it's a distance animation. So animate distance, and I'm going to say every 5 pixels, change the animation, and then last frame action is going to be repeat. So I just want it to keep going, and I want it to run between frames 0 and 2. So this first one is frame 0, that one's frame 1, this one's frame 2. So I'm just going to say in sequence, just run through those frames. Right, now I'm going to set up the position of the sprite. So I'm going to say position 2D. Well, actually, I've got X and Y on it, so I can say capital X equals little x, because that's the parameter. Capital Y equals little y. Okay, so I'll set that up. Right, I'm going to turn gravity on, so I'm going to say gravity dot y, so I want it to be vertical, and I'm going to set that to high number. You'll have to play about with gravity and your jump speed and things like that. Okay, so I'm just gonna hide this bar at the bottom so you see more of my screen. And I'm also going to restrict how fast I can fall. All right, and again, you'll have to play with this, and you'll have to play with that tolerance thing that we set in level. So let's just flip back to level. Where is it? Yeah, the tolerance number that I had as 2 in sit on top. You'll have to play with that if you start messing about with dropping faster. Okay, so back in my player constructor, so I'm going to say set speed clamp, and I'm going to restrict it to 250 pixels per second. Okay, so just an arbitrary number played about with. Other things that I need to set up, I need to set up some callbacks. Now we need to talk about this carefully. When you're doing control in a platform game, it's important that you do the X directions and the Y directions separately. Okay. So we're going to have to set up two callbacks to do this. So we're going to say update callback plus equals, and we're going to call the first one move horizontal. We'll have to create that. So we're going to say control full stop, create that. We're going to do another one, update callback plus equals move vertical. And again, semicolon doesn't exist, control full stop, generate method. Always check that list in case it does something stupid. We'll also want to broadcast our position because we'll want this character to control the scrolling. Okay, so I'm going to do another update callback plus equals, and I'm going to call it broadcast. And I'm going to generate that. So control full stop and generate. The other thing we'll want to do is we want to know when we're on the ground, because you only want to be able to jump if you're on the floor. Okay, unless your game allows you to double jump and all that, but that's a different kettle of fish. Okay, so I'm going to create a variable and I'm going to set ground to false. It doesn't exist, so I'm going to get it to create that. So I'm going to say control full stop and it'll say generate field. So I'll get it to generate a field and it should have made it at the top. Private bool ground, because it's private, it's only the class can see it. The other thing I'm going to do when I'm walking about, I want to be able to control the speed. So I could hard code that into the code, or I can have a variable. So I'm going to create another variable up here. So private float speed, and I'm going to set it to, it's up to you. I'm going to set it to 120 pixels per second. Okay. Play about with that to get a speed that works with your character. But I'm going to say it's 120 pixels per second. Right. The final thing we've got to do, we've got to set up the positions, the offsets that we want to check for collision detection. Now, when we're moving left, right, and we're falling, these offsets are in different positions. So what we need to do is we need to create space to store these offsets. All right, and they're going to be lists. So at the top, where the other fields are, we're going to create three lists. So we're going to say list, and these are going to be vector2 values. So list vector2. The first one we're going to call left off, and we're going to say equals new, and it should come up in the picker list vector2. So pick that and then just do parentheses and a semicolon. Now I need two more, one for right and one for down. I'm not doing one for my head because I'm not bothered about detecting my head banging things. So I'm just going to copy that and paste, and I'm just going to change these. So I'm going to say right off and down off. Okay, so that's just three lists that are going to hold some offsets. So you can see that we had those list things set up in level earlier. Okay, so that's just created space. Right, back to my constructor for play. So this is quite a complicated constructor. After we've set ground to false, we're going to set those offsets. So we're going to say set offsets, and it doesn't exist. So we're going to say control full stop and then generate method. Okay. So whenever you create a method, you always have the parentheses. Even if you have no parameters, you still have parentheses on the end. So just get used to typing those in. So you see, it's created that there for me. So we've got a load of methods not set at the minute. Okay. Right, so let's move on and let's create the offset one. So if we just delete the throw new exception line. So these offsets, when we've got a sprite, so let's just show the sprite. Let's zoom right in on Mario. So when he's moving around and I'm moving right, I want to check roughly where his feet are. So down here where the cursor is, let me get a brush. Let's make a fat brush. Oh God, not that fat. Okay. Right, so here, I want to be able to detect. So if I'm moving right and I hit a wall, I want to detect here. I'm not bothered about his head. So if you've got a wall that's slightly too low, I'm not bothered about that. I'm only going to check down where his feet are. So when I'm moving right, I need to check on this side. So that's from the center of Mario, that is half of the width extra. So this is what these offsets are going to be. And it's going to aim us down near his feet, which is half the height from the center. When we're moving left, we need to check from the center, but minus the width, okay? But still down. When we're falling down, we're going to check this corner, this right-hand corner, and probably the center. But you can have as many points as you want. The fact that we've set them up as lists makes it quite flexible. It depends on your sprite, what sort of things you want to do. You can check his head when you're moving left and right, if that's relevant to what you're doing, okay? But I'm just not doing it on mine. Right, back to the set offsets then. So we're going to first start off, we're going to create a couple of local variables just to hold half the width of the sprite. So we're going to say float w div2 equals the width divided by 2. It just saves us having a calculation, and we're going to do the same for the height. So we're going to say little h div2 equals height div2. It is something I could probably put into the sprite, but I'm not. I probably have got it, but I can't remember what it's called. So it's easy enough just to create. Right, so we're going to set up our left offsets. So we're going to say left off dot add, and then inside our parentheses, let me zoom in. I'm going to say new vector 2, and I'm going to specify from the center where my left check is. So I'm going to say, well, it's minus w div2. So it's half the width of the sprite to the left, and the height is down. So that's going to be h div2, and I don't want to be right at the bottom. I'm going to say -1. Okay, again, you can play about with all these things. So that's the left offset. I'm going to do the right offset, same way. So right off dot add new vector 2. This time it's going to be plus, so it's going to be w div2 h div2. So that's going to be the same. So just around about his feet. Okay, so that's where we're going to check for that. The down offs, we're going to have 3. So down off dot add new vector 2. So we want to do the left hand edge at the bottom. Okay, so we're going to say minus w div2 h div2. So we actually want to check right at the bottom this time so that we can sit his feet properly. Okay, we're also going to check in the center, which you could argue we don't need the center one, but I'm just going to put it in. It doesn't matter. Vector 2, so that's no offset from the center X position, and then down h div2. Okay, and the final one is going to be the right hand side. Vector 2, so that's going to be w div2 h div2. Now by doing these, looks a little bit complicated making these lists, but it actually simplifies the code later on. Okay, so let's just set some offsets up and talk to me if you need some different requirements, and I'll talk to you about how you might be able to go about creating a solution. But this will work for just a stock standard platformer. Right, let's just move down and fill these other 3 methods in, and then we're finished and we can run a test. Right, the broadcasting. Now, currently, we have got in our, we call it level viewer, a little sprite that we set up that was broadcasting its position. Let me zoom out, which was here. We want to broadcast our position instead. So what I'm going to do, so that I can use my Mario character, I'm going to go to level. Oh no, in fact, I'm going to, in level viewer, I'm just going to come out the line that says broadcast. So I'm just going to say, no, don't run that method. So it'll be on screen and it'll move around, but it's not going to broadcast, it's not going to do anything. All right. So we'll actually, when we control Mario, we'll actually be controlling that as well, but we don't care about that. Okay. If it really annoys us, we can just comment it out from level, and we'll have a look at that at the end of the video. So I just want to stop that broadcasting. So I'm going to go back to my player character, and I'm going to put my broadcast code in. So I'm going to get rid of the new exception bit, and I'm going to say message bus dot instance dot broadcast message and extra messages type, and it's going to be view position, and we're just going to say, well, the center of this sprite. So we're going to say center 2D. Okay, so that sorts the broadcasting part out. Right, let's do we've got move vertical, so let's do move vertical. Seems like that's there in front of us. Okay, so this has got two jobs to do. It's got to check for whether we've fallen into a platform because we're falling into gravity. Okay, and set whether we're on the ground or not. It's also got to enable us to jump if we're on the ground. So we need to do the falling down bit first. So we're going to say if, and then in brackets, level dot touching platform. Oh, I didn't call it touching platform. Did I call it in platform? Did I? Yeah, I called it in platform. So in platform, and then open a bracket, and we're going to give it our center 2D, and the down off. Okay. Then we're going to open a brace because we're saying, right, if that's true, if we're in a platform, let's attempt to sit on top of it. So we're going to say if Level.SitOnTop, and we're going to say this actor, and we're going to give it the down off again. So if that is true, we're going to say ground equals true. Now, I haven't put braces. Don't put these. I haven't put braces in. If we've only got one statement to execute, if something's true, we don't have to put the braces. We've put them here because we wanted it to be clear. Okay. Technically, we didn't need them, but we're going to put those. Okay, so we're saying like, okay, check, try and sit at all those offsets on a platform. If you can, excellent, set the ground to true. We'll need that so that we can jump in a minute. If we weren't touching a platform while we were falling, we're going to say down here, after the final brace, we're going to say else ground. We will if the enter key works, else ground equals true. Ground equals false because we're falling. Okay, so we've got a little bit of work there. So we've got an if we're in a platform, let's see if we can sit on that platform. It might be that you're jumping or you're already in a platform, so you can't actually sit on top of it when you're in like partially hitting a platform. So if that's true, fine, excellent. We sat on top. We'll say that we're now sat on the ground. If we weren't in a platform, we must be falling in the sky. So we'll say we're not on the ground. Ground equals false. Okay, right, put a couple of blank lines and then I'm just going to put a comment saying jump code. Don't need that many blank lines, just so I know that this is the jump code. Right, so we only want to do this if we're on the ground and we've pressed the jump key. So we're going to say if, and then open our bracket, and then we're going to say ground. So if that's true, and we do and by saying ampersand, ampersand, and then we're just going to ask what if the jump key is pressed. Now I'm going to use left control for this. So I'm going to say gm.inputManager.key pressed, and then I'm going to say keys.left control. If we're on the ground and the key's just been pressed, then we're going to say press and we're going to say left brace, let's jump. So to jump, what we need to do is set a velocity vertically upwards. So we can say velocity.y equals, and I'm going to set it to minus 200 pixels per second. Minus means upwards. What I'm also going to do is make sure I'm off my platform. So I'm going to say y minus minus. So I'm just moving up a pixel. So I'm above the platform. So I get a chance to actually move up. You may need to mess about with this, and you may need to say minus equals 2 or something like that, but I'm going to see if I can get away with that to start with. And that's it. That's all we need to do to jump. Okay. Right, final bit to do is to just do the moving left and right so we can actually run. This is a little bit more straightforward. So let's go to move horizontal. Comment out the exception line again. Oh, not comment it out, but delete it. So we're just going to check if we want to move left. So we're going to say if gm.inputManager.key, I'm going to put key down. All right, so because I want to be able to keep my finger on the key, so it's not like jumping. If I'm holding down the cursor, I want to keep running. I don't have to keep pressing it like track and field, although that would be amusing. So I'm going to say key down, and I'm just going to use left and right cursor key. So I can say cursor.left, but we only want to do that if we're not touching a platform on our left. So we're going to say after, so we've got gm.input key down. So that's one check. Then we're going to say, and we're not level dot touching platform. I think I called it in platform, didn't I? So in platform, and it's going to be at our center and our left offsets. Okay, so as long as both of those things are true, that we're not in a platform on our left offset, we're going to do brace, enter. So we're going to say, right, if the key's down and we're not in a platform, then we can move left. We just check to see if we're free on our left-hand side. So to do that, we're just going to say x minus equals, so negative is moving left. And we're going to say speed, which is that speed value we set, and we're going to say multiplied by gm.eventManager.delta. So what that does, that works out our speed in pixels per second for the current frame that we're moving. Okay, so if whenever you want to move at a rate, that's how you do it, using the multiplied by the delta, the value you want. So if you want to move at 200 pixels per second, you'd set speed to 200, you multiply it by the delta, and it'll move that far for you. Okay. The other thing we're going to do, if you just quickly look at my Maro graphic, they're all facing right. So when I'm moving left, I actually want to flip the graphics. So I did promise I'd show people how to do this. So if I want to flip the graphic, I'm going to say fx equals sprite fx dot, and it's flip horizontally. If you want to flip a graphic vertically, it's flip vertically. Okay, that's it for the moving left code. Let's add in the routine for the right code. You'll see it's very similar. So we can say if gm.inputManager.key down keys.right, so I must pick a different key. And again, I'm going to say, right, okay, as long as we're not, which is what the exclamation mark means, level.in, oh dear, struggling, in platform center 2D right off. So we've got our offsets for the right hand side. So again, if both of those things are true, put our braces in, we're going to move the other way. So we're going to say x plus equals speed times gm.eventManager.delta. Use the picker. This time, if we're going right, we don't want any flipping. So we have to make sure that we turn the effects off. So we say effects equals sprite effects dot none. Use the picker. It'll save you a lot of time. Theoretically, this should just work. Okay, so let's just quickly review what we've done for the sprite. So we set up some frames. We set the animation up so that every 5 pixels will animate. We set our gravity up. We set up our movement horizontally and vertically separate, and we got our broadcaster. We created space for speed for a variable called ground that tells us whether we're touching the floor or not. And we set up these little lists for our collision detections for left, right, and down. Okay. We then populated those lists with the set offsets routine. So left and right, we just checked his feet at the bottom. Down, we checked a number of positions below the sprite. Set up the broadcast code so that we can scroll. Wrote our vertical code. First bit, this bit is checking for falling and determining whether we're sat on the floor or not. This last bit is just allowing us to jump if we're on the floor and we press the key. So jumping, just setting a velocity, and that's all managed for you. For the moving horizontally, again, it is checking if the key is pressed and making sure we can actually move by doing this with the offset, and then just manually moving the position. And we're setting the sprite to flip. Right, let's just see if it runs. If it runs, it'd be a miracle. It's compiling away. Oh my god, it's run. Right, so press 1. Oh, there's Mario. Oh, he's not working. Oh, it's crashed. Oh dear. Let's have a look. Done something stupid. We got player. What have I done? What have I done? So ground equals false. Set that up. Let's have a look. I might be something to do in my level code. Bob. XMW. Let's just check that I've got my level data right. X, M, and W are walls. Oh, I know what it is. I didn't set the alignment for the sprite, I think. Right, so we want the Y position of the player to be the bottom of the sprite. So if we just in the player constructor, we say align equals, and then select align dot bottom. So that's center bottom. So let's try that. That's probably what it was. I don't know what the crash was. I hope that's what it was. Oh, there you go. So there you go. You can see as I go left, it flips. I've got that annoying white blob, so I'm just going to get rid of that. So the problem I have with the crash there, the X and Y position bogged up, and I needed to set the alignment for the sprite to be bottom. Okay, I think I showed that in the previous video for the enemy because we had the same problem. Yeah, there you go. I had to align bottom for the enemy. Right, so in level, where we've got level viewer in the constructor for level, I'm just going to comment that out so that's not on at all because that's annoying me. Right, okay, so let's run that. Right, so press 1. So there you go. You can actually see Mario with that white blob on him. So he's flipping, and you can see that he's animating. It's not the world's greatest animation. Okay, he's actually only got 3 frames of animation. That's it in Donkey Kong, but it's good enough. So it's running, standing, walking, running, standing, walking, running, standing, walking. And you just need to then get a balance between what your stepping rate looks. Right, so if I walk off this platform, so you can see that I'm checking my offset. So I had 3 offsets for down that I was checking. I'll come back. So I can't run through that wall because my right offset is stopping me going through that wall. I can jump because I'm on the floor. So left control, jump. And you can see he just falls down. He's animating when he's falling. Animation can get complicated really quick, so we're not worried about that. That's all right. So you can see he's falling and he stops on the platform. Right. So if we go along, if I'd have just done the center, when I got to there, I would have fallen, and I'd have fallen through the platform as well. So those offsets that I picked let me stand right on the edge for pixel perfect jumps. If I move a little bit further, he's going to fall. So I could move that in if I wanted to change the tolerance on that. And you'll see that I've got that. Oh, crash. What have I got? System out of range. Tile 911. Oh, I've got something very dodgy going on there. Tile 911. Out of bounds. That's a bit odd. My tile list. Oh, I know what. I've got a problem there. Right, so tile list has got 7 items in it, but what is the value of get graphic? So get graphic, let's add watch. So a bit of debugging going on. Ow, -1. Ah, that's a bit silly of me. So get graphic -1. Now then. Right, okay, so because I've got loads of -1s and I'm checking for those, that is a pain. So in my level data, I've got all these dots. Okay, so what I can do is I can put a dot as part of my tile list, and this is just to stop that error occurring. I can't have -1 in an array, that's the problem. Okay, so I'm just gonna say, oh, semicolon dot empty tile. So I'm gonna go back to level, and for passable, I can't now put that. So I'm gonna delete that bit of code. So this is a bit of debugging going on here. Right, so I need to set up what passable tiles are. So that's the dot tile. So where I set my collision detection, and I did my platform ones, so collision data, I'm going to say passable dot add, and I'm going to say tile index dot index of. I've got one more thing I must do. Dot. Okay, so that's going to set the passable ones up. But what I also need to do is create another dummy tile. So down at the bottom, where I've got all my dummy tiles in generate tiles, I'm just going to copy paste, and I'm going to create another one, and I'm going to say color dot transparent, because I don't want to see it. Okay, so let's run it again. I hope that was the mistake. I think it was the mistake. Right, so I'm running. Why? I don't know why it happened actually down there, but all right, there you go. So that has fixed it. So we've got tiles, but they're transparent. Right, so if I jump, and you can see you've got to get your jump velocity to match up with your platform height. So that is just enough for me to get up those steps. But you can see that Mario's as high as a platform. So you might in reality make your sprite a bit bigger than that, but you'd still need to mess about with velocity. And you've got to balance that with your gravity so you don't float too much. Right, so you'll see here, because I'm not detecting the head position on my left and right offsets, which I could easily do, I can do a jump like that. So you could have platforms that are on the edge. Now I've got a problem because I can't get out of this part of my map. Okay, so that is a bit of a problem. Right, okay, so let's just have a look at that fix I just did. I could do this a couple of different ways. This was just one way of doing it. So I've added a transparent tile to my tile list in generate tiles. I've altered my passable list at the top to just be an empty list, and then in set collision data I've added the dot as my passable tile. So in the level map, so my level1.text, I've actually added the dot, the blank character, to the end of my tile list. There is another way I could do it. Okay, and ask me about that during lesson. Okay, so I can show you that. There is a way of doing it, and it's to do with the way that these work. Right, and it only actually affects the contains bit. Okay, so I'd have to do it in, so where have I got contains? So I've got contains there, I've got contains there. So I've got what? I've got two contain things. So I could rewrite it like this, and I'll prove you that this works. So I could say, oh no, that won't work. No, that is the fix. That's the best way. I can do it another way, but it starts getting a bit complicated. That's an easy way of fixing it. Okay, so make sure you do that on your vid. So you've just got your platforms and your passable ones. If there are other lists that you want to detect collision for, you can set those up, but you obviously need to talk to me about that. Okay, so let's just recap what we got. So we've got a list of platforms that we can stand on and we can't walk through, a list of platforms that we can go through. We set those up with set collision detector. We commented out the level view because we don't need that now, because you can see that the screen scrolled with the Mario character. So we set up our platforms by using this tile index of. We set up our passable ones with our new fix with the dot tile, the one that's the empty space. We created a floor checker for a tile location, which I actually haven't used anywhere, but it could be useful later on. That's interesting. I never even used that. No, I didn't use it. Oh well, that's okay. It has got a use, but not for how we've got this set up. So, I mean, that's there. It's not hurting anything. Then we got one for checking a pixel position to see if it's in a platform, and it returns true or false. Then we got one that takes a list of offsets from a center position and checks all of them to see if they're in a platform. Then we've got this final one that, given a list of offset positions, attempts to sit as on top of a tile. If it can, it does and returns true. If it can't, it just returns false and says, oh, we didn't do it. Okay, and then at the bottom, in my generate tiles subroutine, I added my transparent one for the dot. As long as you set it to color transparent, you'll be able to see any background graphic that you show through. In the player, so we only done 2 classes here. In the player, we created space for the offsets, we created a field for ground, and a field for the speed. Okay. We got the level to generate the player's position from one of the special tile characters. We set up some frames to do some NAF running animation. We set a distance animation. We set the alignment to bottom because we want the Y value to be the bottom of the character. We set up our gravity value, and we can mess about with that to make it higher gravity so we fall quicker. We set a clamp speed to set a maximum falling rate, and I'll just show you what happens if you set that quite high. So let's just set that to 500 and run it. What you might find is that I fall through platforms because I'm moving too fast. So it won't happen up here. So that's fine. But once I get a bit of speed up, so straight through the platform. So I've got to get a balance, and it's to do with that tolerance value. I could probably put 300, so I can fall at, we'll see, 300 pixels per second. That might not make it. We'll see. It depends how far your biggest fall is. No, that was no good. So I'll put it back to 250 and drop it. Try it again. So clamping it at 250 works for the maximum drop. You could use that as a way of killing the character if they fall too far. So you could set up a thing to say, if I've gone off outside the world, die, and things like that. So you could actually use that mechanic. So it's not necessarily a bad thing. We had to split the movement up into horizontal and vertical. We did a bit of broadcasting for the scrolling. We initially said we're not on the ground. Not that that matters because it's checked straight away anyway. And then we just set up our little collision check offsets. So our left and right and our 3 down ones. There's the broadcast routine, just doing the view position stuff. And then we got our vertical routine. So the first bit checks to see if we're falling and whether we've hit a platform or whether we're still falling, setting the ground to either true or false. Then we got our little jump code, which isn't much code at all. Just, are we on the ground? Have we pressed the key? Set our velocity up, move off the platform a little bit so we don't get trapped. And then the move horizontal, same thing. Have we pressed the key? And check our offsets to see if we've actually got empty space in front of us. And if we have, move left by speed pixels per second, and we want to flip the graphic. If we move right, check the key, make sure the offset's okay, and then move right at pixels per second and turn the effects off because we don't want it flipped. Okay, so just run it again and then that's it. I'm tired and that's it. I've had enough. So there you go, little Mario character. The animation can be as good as you want it to be. Okay, but you can see that I'm scrolling. Obviously, I can't get to half my platform, so I've got to, it's not balanced this very well. I can do the steps, but that's about it. So you see it scrolls. Oh, I'm yawning. Jumps. Jumps, jump, jump. If I fall in there, I'm in trouble. I can, that's an interesting one. So it might be that you want to be able to jump up. So I can jump, if I'm dropping down, I can actually jump quite a few tiles distance, probably about 3 tiles. So you could use that mechanic, but I can't jump that gap. Oh, I nearly can. So you have a little bit more speed and I could probably have jumped that gap. But now I'm stuck. Oh no, Mario is stuck. And he couldn't even pick up the sprites. So I'll do another video where I show you how to do clean detection between sprites and sprites. So this one's really been clean detection between sprites and tiles. Okay, so the next one will show you how to pick up things like that. I don't know why it's jerking. But there you go. Right, end of video. I'm tired.